Everything around us, from the smallest grain of sand to the largest star, is made of atoms. Atoms are the fundamental building blocks of matter. Imagine them as tiny Lego blocks that combine to create the diversity of our universe. These building blocks are incredibly small. Millions of atoms could fit on the period at the end of this sentence. Despite their size, atoms are incredibly important. Understanding atoms helps us understand how the world works. It helps us understand everything from why water boils to how stars shine. Atoms themselves are made up of even smaller particles called subatomic particles. The three main types are protons, neutrons, and electrons. Protons and neutrons reside in the atom's center, forming the dense nucleus. Protons carry a positive electrical charge, while neutrons carry no charge, making them neutral. The number of protons defines an element's atomic number. For example, all carbon atoms have 6 protons. Electrons, much smaller than protons and neutrons, orbit the nucleus at incredibly high speeds. They occupy specific regions around the nucleus called energy levels or shells. We'll delve into these in the next section. Imagine the nucleus of an atom as a tiny sun. Electrons orbit this sun at different distances, much like planets orbit our sun. These orbital paths are called energy levels or shells. Each energy level can hold a specific maximum number of electrons. The first energy level, closest to the nucleus, can hold a maximum of 2 electrons. The second energy level can hold 8, and the third can hold 18, and so on. The further an energy level is from the nucleus, the higher its energy. Think of it like climbing a ladder. The higher you climb, the more energy you have. Section 4. The Aufbau principle filling energy levels. Electrons, being negatively charged, are attracted to the positively charged nucleus. However, they don't all crowd into the lowest energy level. This is where the Aufbau principle comes in. The Aufbau principle states that electrons fill energy levels in a specific order, starting with the lowest energy level closest to the nucleus. Imagine filling a series of containers with water. You wouldn't fill the higher containers first, would you? Similarly, electrons fill the lowest available energy levels before moving to higher ones. Section 5. Electron configuration, mapping the atom's structure. Electron configuration is a way to describe which energy levels and sublevels electrons occupy in an atom. It's like an atom's address for its electrons. We use numbers and letters to represent this configuration. For example, the element lithium or Li has 3 electrons. Its electron configuration is 1s2s1. The number 1 represents the first energy level, S represents the type of sublevel, and the superscript 2 indicates that there are 2 electrons in that sublevel. The second part, 2s1, indicates that the third electron is in the second energy level, in the S sublevel. Electron configuration helps us understand an element's chemical properties and how it might react with other elements. Section 6. Valence electrons and chemical reactions. The electrons in the outermost occupied energy level of an atom are called valence electrons. These are the electrons involved in chemical bonding, the process by which atoms combine to form molecules. Think of valence electrons as the outermost Lego blocks on a structure. They're the ones that interact with other blocks to build larger structures. The number of valence electrons an atom has greatly influences its reactivity. Atoms tend to gain, lose, or share electrons to achieve a stable configuration of 8 valence electrons, known as the octet rule. This drive for stability is the basis for the formation of chemical bonds and the creation of the incredible diversity of molecules we see in the universe.